People who make fireworks know how to produce spectacular color. They know that different substances in flames emit light differently, as if every material had its own color fingerprint. Clouds of gas far away in space can emit light. The reddish color here matches the light from hydrogen. To understand more, we need to go on an adventure, on an exploration of everything, large and small, with eyes wide open. It's a voyage of imagination into a world outside everyday experience, zooming in and in through layers of matter. Others have gone before. For many generations, observations have shown how the world behaves. And, slowly, over very many years, even centuries, people built ideas, reconstructing inside human minds, in the world of the super small. There is a problem. No one has ever seen an atom. Not with light microscopes, not with any microscopes. Atoms are too small to be seen. But all that patient observation has allowed people to make models, ways of thinking about nature. If you look for images of atoms, you'll find a confusing mixture of interpretations, but all of them have something useful to say. Also, people make representations based on the human face, or models of the solar system, with something useful to say, so we shouldn't worry too much about mixed images of atoms. Deep inside materials, we discovered the origins of electricity, and how electrical behavior can turn hot material in a flame, or clouds of gas across the galaxy, into sources of light. Nature can behave electrically. It can behave electromagnetically, making motors spin, such as in hairdryers and vacuum cleaners. It turns out that we can make a whole lot of predictions about matter, based on models of atoms, without ever seeing anything so tiny, and the predictions have a huge impact on life. We can explore and understand the close, very close, interactions of matter with light. Electricity is key to matter and to light. Old TV technology was built on the idea of tiny electrical particles. These came out from a heated metal. They could be accelerated to high speed, steered by magnetic forces, and crashed into a screen, so that the energy of the particles made the screen glow brightly in different places to produce moving images. The scientists, more than 130 years ago, gave a name to the particles: electrons. It's impossible to draw what electrons really look like. They are way too small to look like anything to us. We can just draw little spheres or tiny dots to represent them. Being electrical, the electrons can be controlled by electricity, and when they are moving, by magnetism. They can move in circuits, and we see some useful effects in the human-sized world. Recent TVs don't use electron beams, but electrons are still key to what happens. We can never understand emission of light by matter without thinking about electrons and atoms. The electrons in old TVs came out of that hot metal, so electrons are just part of matter, stuff, just as atoms are. Experiences such as TV technology helped people to create reliable models of atoms. Even if they look different, they all have something in common. A bigger part in the middle, the nucleus, and electrons in layers around that, maybe a little like this. It helps to have a look at just one electron. Electrons in atoms can lose and gain energy by moving between layers. When they lose energy and fall from layer to layer, then a little burst of light is created. And it moves on out, at the speed of light, of course. It moves so fast that another look usually helps. The layer arrangements in different materials are not quite the same. So the way electrons fall between layers are different. The energy jump is different. So light coming from atoms varies from substance to substance. So there are those fingerprint colors. In fact, The whole world of colour, including your screen right now, is created by what happens in the electric world of atoms.